So this is a simple, straightforward problem that we might get out of this section with arcs and centers and chords and tangents. So you can see that I have a circle. It has a chord, which is LM, which cuts across the circle, has a center point K, another point under that N, which is on that point LM, and then it also has the length R, which is the radius, which is what I'm being asked to find, which is R. So what I'm going to go ahead and take a look at all of my different options for formulas and my different options for theorems. I'm going to look and kind of take a look to see what I'm looking for. I've got arcs and chords and central angles and all sorts of things like that. I've also, don't forget, I got my tangent cards here. I've got a lot going on there. So when I'm looking at this, I want to look and kind of see, okay, well, I've got a center point, I've got this angle, and I've got a perpendicular bisector here. Well, it's perpendicular. So I can go back here and say, well, maybe it's going to be in one of these bisector ones. So I've got one that says, if AB is the perpendicular bisector, well, I know it's perpendicular, but I don't know that it's a bisector, so I'm going to kind of set that aside. This one down here says, if AB is perpendicular, then CD and D, or CE and DE are equal. So if these two are perpendicular, this is the one that says if there's a line that's the center of the circle and it's perpendicular to a chord, then it bisects that chord. So this is the one we want here. Based on this information, it's telling us that these two pieces have to be equal. Because it says if we have a line that's perpendicular to a chord, then it bisects that chord. That makes our work even easier because I know the length of that chord is 14, which tells me if I'm going to bisect it, that each half would be 7. Now to find the length R here, I should be able to set everything aside and solve for my nice little right triangle. And you should recognize right away that this is a right triangle, which means that we can use Pythagoras. A squared plus b squared equals c squared. That's our Pythagorean theorem. And then we can fill in the a and the b side and solve for the c, which is the radius. So I've got 3 squared plus 7 squared equals r squared. This is 9 plus 49 equals r squared. 9 plus 49 should give me 58 equals r squared. So to find r, I need to square root both sides. So r equals the square root of 58. Now, since they're asking us in the directions to find a length, they're going to tell us that we need to round it to, say, the nearest tenth of a unit. So I can go right in here, I can put in my square root symbol, put in my 58, and I've got 7.61. So my radius is 7.6 rounded. Now I always want to go back and double check that that is a reasonable answer. So if you look at this, my chord here, that distance is 7, 3 is the other. I know the hypotenuse has to be longer, so I'm going to go ahead and say that, yep, that's a verified reasonable answer.